Colby, math.com.
We've been learning and practicing divisibility rules in class, and on this assignment you'll be completing this sheet, which if all went according to plan, we've done quite a bit of this together in class. If I stuck with my plan, I would have left this one and probably this one and some others, but certainly these two. And we'll focus on the largest one, 35,120, on this video. We're checking the divisibility of 35,120 by each of these numbers. And if 35,120 is divisible by 3, what we mean by that is we could divide it by 3 and get a whole number quotient, which is another way of saying that 3 would be a factor of 35,120. And it's yet another way of saying that 35,120 is a multiple of 3. The divisibility rule for 3 is you take the sum of the digits, so 3 plus 5 plus 1 plus 2 plus 0, and that's 8, and 1 is 9, and 2 more is 11, plus 0 is still 11. And if that sum is a multiple of 3, then 35,120 is a multiple of 3, or is divisible by 3. Of course, 11 is not a multiple of 3, so we will not place 35,120 in this oval shape is called an ellipse. We will not place it in that oval. To check divisibility by 4, write down the number 35,120, and you don't focus on the whole number. You focus on the number formed by the tens and ones digits. So you focus on just this number, the 20. And if 20 is divisible by 4, then the entire number is divisible by 4. Of course it is. So we'll place 35,120 in the ellipse for 4. 35,000. Oops. Thought I clicked on that, but I didn't. 35,120 is divisible by 4. The reason this rule works is every 100 is divisible by 4 because 100 is 25 fours, and every 1,000 is just 10 hundreds. So everything from the hundreds place on up is for sure divisible by 4, and we only need to concern ourselves with the number formed by the tens and ones digits. If we look at the pattern for multiples of 5, starting with 0, which is the first multiple of 5 because it's 0 fives. 1 5 is 5, 2 5s is 10, 3 5s is 15, 4 5s is 20. There's a repeating pattern for the units digit. It's either 0 or 5. And so any number that has a 0 or a 5 in the units digit is divisible by 5. Of course, this number is 35,120, has a 0 in the ones place. What I'd like you to do during the pause is refer to your notes. We've taken detailed notes with many examples for all of these divisibility rules, and attempt to apply the divisibility rule for 6, 8, 9, 10, 11, and 12 to 35,120, and then come back after the pause and see how you did.
Paused.
Divisibility for 6 requires the number to be divisible by both 2 and... Wait a minute. I'm forgetting my own rule. Hang on. Yeah, both 2 and 3. I'm sorry. It would have to be even, and it would have to be a multiple of 3 or divisible by 3. Well, we didn't place 35,120 in the 3 oval. It's certainly divisible by 2 because the ones digit is an even number, but because it's not divisible by 3, it cannot be divisible by 6. Divisibility by 8 is very similar to the rule for divisibility by 4. We're going to write the number 35,120. Then we're going to consider the number formed by the ones, tens, and hundreds place, because every 1,000 is divisible by 8 because it's 125 eighths. But if we take 120 and check whether it's divisible by 8, we'll know whether the entire number is divisible by 8. And when I divide 120 by 8, I get 15 with no remainder. So 35,120 is divisible by 8. So I'll place it in the ellipse for 8, 35,120. Divisibility by 9 is the same rule as divisibility by 3. you add up you find the sum of the digits, and that number would have to be a multiple, in this case, of 9. And 11 is not a multiple of 9, it's not divisible by 9. But anyway, it wouldn't make sense for it to be divisible by 9 if it's not divisible by 3, because every number that's divisible by 9 is also divisible by 3. So we will not place our number in the 9 ellipse. We'll certainly place it in the ellipse for 10, because we know that any number that's a multiple of 10 has a 0 in the ones digit. Divisibility by 11 is the most difficult rule of all to remember, although once you've done it a few times and you get the hang of it, it's not that hard. The rule is that the difference of the sums of alternating digits must be a multiple of 11. So I'm going to write this in a strange way, so watch me do it first and then you can do it. I'm going to write the alternating digits first in one color, and then the other alternating digits in another color to sort of highlight what we mean by alternating digits. So the 5 and the 2 alternate, they skip over a digit, and the sum of 5 and 2 is 7. The 3, the 1, and the 0 alternate, and 3 plus 1 plus 0 is a sum of 3. And the difference of those sums, 7 minus 3, is 4. But 4 is not a multiple of 11. It would have to be 0, 11, 22. So this entire number is not a multiple of 11. Just to make sure the rule is clear, let's do the same thing for 9042. If I write the alternating digits for 9042 in these two different colors, the sum of these alternating digits is 2, and the sum of these alternating digits, 9 and 4, 9 plus 4 is 13. Now we have a difference, 13 minus 2, which is 11. That is a multiple of 11. And so that's why 9042 will go in this ellipse, but not 35,120. Divisibility by 12, the rule for divisibility by 12 is that the number must be divisible by both 3 and 4. And while our number is divisible by 4, it's not divisible by 3, and so it cannot be divisible by 12. I hope that helped you with the assignment. I'll see you tomorrow.